Young's double slit experiment. Suppose there is a source and you keep the source at the principal focus of a lens, and out of which comes a plane wavefront. You just in the path of a plane wavefront you place a split. There is a opening here, there is an opening here, and the light through this act as a secondary source and here source. So let us call this source 1 and source 2, and the distance between these two sources, let us call this distance is small d. And far away from this sources you are having a screen, and distance between these two will be equal to capital D. Sources, here are the sources and here is the screen. So what happens, the light from this point and this point exactly when it meets the center of the screen, there is obviously both the lights travel the same distance, so here the constructive interference will happen, so this part will be bright, that we call central maximum. Suppose if you go somewhere here or somewhere here or somewhere here, what kind of a pattern, whether it is going to be a bright spot or a dark spot or it is in between, we are just going to find out. So let's see how the light travels from here. So from here, let's see, it reaches the point. So let's call this point P. So the distance traveled by the light from the first source will be S1P. From here also it goes there, so it is S2P. So what is actually the distance difference in distance traveled by them? Let us say this is S1P, this is S2P. S2P seems to be longer, so the path difference we call S2P minus S1P. And let's try to write what is S2P and S1P. Suppose if you draw a perpendicular here, you know this is a right triangle, and from here to here it's an equal distance. Let's call this point, let's say M. So this S to M is the path difference. If this is like S to M, so this is S to M, which is the path difference, and this is theta. So I will draw this right triangle over here, and this is D. If you assume this angle as theta, this distance will be opposite side. So S to M is the opposite side. So sine theta equal to S to M by D, or S to M, which is called path difference, is equal to D sine theta. So the path difference delta equal to D sine theta. What if theta is very small? When theta is very small, you just draw, this is the exact distance between mid of the sources. From mid of the source you draw a straight line here. This part you have a right triangle. Okay, now that I am going to draw one more line from here to this point. I'll try to just draw this part separately up here. So this is the thing, this is S to M, and we call this theta. This is the center line you are drawing, which is in this triangle. This is a right triangle, and this is the line, and let us call this P. This is O, this OP. This distance is Y. So this part in this distance is Y. If this is theta, this is 90 degree, and this is going to be 90 minus theta. In this 90 minus theta means this is going to be theta. So this is theta, this is 90 degree, this is 90 minus theta. Since this whole angle is 90 degree and this is 90 minus theta, this is going to be theta. So if this angle is theta, so in this right triangle, you know this is capital D and this is Y. So tan theta, if you take tan theta equal to opposite side divided by adjacent side, Y by D. When theta is small, so Y by D is far less than 1, and then again here based on the sin theta equal to delta by d, that is also far less than 1. In those two cases, theta equal to y by d and theta equal to delta by small d. Equating these two, y by d equal to delta by d. So y is equal to d by d into delta. So delta is the path difference. This is path difference. So we have in general y is equal to d by d into delta. If delta is n lambda, that is a constructive interference. Delta is 2n minus 1 into lambda by 2, that's a destructive interference. If this point is going to be bright, means it will satisfy the condition at that point y position y equal to n lambda. If nth lambda means nth bright fringe, because this position n lambda is for constructive interference, so it's a nth bright fringe. So the position of the nth bright fringe yn is equal to dn lambda by d. And what about the position of the nth dark fringe? Position of the nth dark fringe, yn is equal to d by d. In place of delta, we are supposed to substitute this 2n minus 1 into lambda by 2, say nth dark fringe. So it will be something like this. Suppose you have a pair of coherent sources. This is a screen. You know that exactly at the center you will have a bright fringe. Then after that it will be like this. See, it's a bright fringe. This is a next bright fringe. What lies in between is a dark fringe. So here 0 lambda path difference. Here this is actually lambda by 2 path difference. This is another lambda by 2. From here, this first bright fringe has a total path difference of lambda. Second bright fringe 2 lambda, and the second dark fringe, this is lambda by 2, this is another lambda. So lambda plus lambda by 2 equal to 3 lambda by 2. So the second dark fringe has a path difference of 3 lambda by 2. You look at this formula, it satisfies. See, for n is equal to 2, what you are getting here, d by d into 2 into 2 minus 1 into lambda by 2. So d by d into 2 into 2, 3, 4 minus 1, which is 3. So 3 lambda by 2. So the position of the second bright fringe, this is the first bright fringe, second bright fringe. Second bright fringe means, see, 0 central maximum, first, second bright fringe means here you are supposed to substitute n. So 2d lambda by d. So first let us analyze only the bright fringes and then we'll go for the dark fringe. See here on this, exactly at the midpoint, bright, dark, bright, dark, something like that. So this is a central maximum, 0th order, 0th bright fringe, first bright fringe from the center, second bright fringe. This path difference lambda, this path difference lambda. So path difference I'm mentioning it is lambda, but this position y is equal to, given by this relation, bright fringe means dn lambda by d. If n is equal to 1, y is equal to d lambda by d. What about the second bright fringe? N is equal to 2. So 2d lambda by d. So this distance from the center, from the 0th thing, this distance y is equal to d lambda by d, and this is another d lambda by d, so d lambda by d, and the next one more bright fringe also d lambda by d. So the distance between from the center to here 2d lambda by d, because d lambda by d plus d lambda by d, this position from here, this distance is equal to 2d lambda by d. Nth means n d lambda by d. What about the difference in distance? So this is one full bright fringe. So this is d lambda by d, this is d lambda by d. So the difference is one dark fringe. You see this carefully here. This is the central maximum. This is the first maximum. The distance from the central maximum to first maximum is what you call one dark fringe, because where the bright fringe begins to decrease, this is where the bright fringe is. From here the brightness keeps on decreasing and becomes completely dark and then becomes completely bright. So the distance between two bright fringes will be a dark fringe. The distance between two bright fringes will be a dark fringe. So this is the first dark fringe, this is a second dark fringe. What about this width of the second dark fringe? We know that total distance is 2d lambda by d. This is 1 d lambda by d. This is d lambda by d. Distance between two bright fringes lie a dark fringe. So thickness of the dark fringe is equal to d n lambda by d, nth bright fringe, minus d into n minus 1 into lambda by d, n minus 1th bright fringe. If you calculate, you get d lambda by d. This is the fringe width. And you can also prove it. Fringe width of the bright fringe is nth dark fringe minus n minus 1th dark fringe. Nth dark fringe d by d into 2n minus 1 into lambda by 2, nth dark fringe, minus d by d, and n minus 1th dark fringe means 2 into n minus 1 minus 1 into lambda by 2. When you do this, you get d by d into lambda by 2, you can take out. So it is 2n minus 1 minus of 2n, minus into minus plus, actually plus, when you multiply this 2 and then this thing minus 2. So when you do all this, you get what? D by d into lambda by 2 into 2. So you get what? Bandwidth of the bright fringe is also lambda d by d. See, whether it is a bright fringe or a dark fringe, they both have the same fringe width. We'll continue the discussion in the next video.